Hey, Nicholas. Good day. Just getting stuff on the board for you guys. Nicholas, Julian, L, and Magdalena. Hello. Magdalena, Nicholas, Julian, L, and Dominic. Super. And I've got Noah and Marla. Dynamite. I've got Julian K. I've got Shilpa. I've got Lily. Good. Keep them coming. Keep them coming. Okay. Lest that you get bored while you're waiting, see if you can figure out a name for A and B. Check out A, check out B. What would their official names be? Good. I got Larissa. Think of what we learned last time and a couple times ago. And we should have some others joining us rather soon. I got a lot of you left. There's some more. Good. I got Lee and I got Vincent. I knew you'd be there, Lee. Welcome, Vincent. Who else I got? I got Lena. Super. Welcome, Lena. And I got Priya. Thank you, Priya, for checking in. So everybody, see if you can now answer these. Why don't you put some guesses? What is A? What is B? While I check in some others. I've got Tadashi and Isabella. That is great. Keep them coming. Keep them coming. Still looking for Natalie, Sarah, Deacon Riley, Tom, Christian, and Ali. There's Deacon right now. Lily, it has a carboxylic group, so that makes it a what? A what? Deacon, hello. Nice to have you there. So name, and how about you also give me, so 1, name, and I'll say 2, type of compound. If you can't do 1, you should be able to at least do 2. So give me an exact name for A and B, and if you can't, tell me what type of compound they are, all right? So punch in your answers, 1A, 1B, 2A, 2B, okay? Still writing down a couple more. B is an aldehyde. No, it's not an aldehyde. Check it again with what we did last time. And I got a couple more. Ollie's there. Good. That is good. Hello, Ollie. As is Natalie's there. Ute, still looking for Sarah, looking for Riley, Tom, Christian. So if you're there, let me know. Yeah, carboxylic group, that's the type of, that's this thing, but that's not the name of the molecule. What's the name of this particular molecule? Yes, it has a carboxylic group. That makes it a what? Maybe we should do 2 first. I think I got enough of you here. Let's go ahead and start. This is a good place to begin for the day, okay? Here's what I mean. Like 2A. All right, everybody, what sort of compound is this? 2A. A is a what? What kind of compound is this thing? Everybody should know that after the last few weeks. What kind of compound is A? It's a what? Hint, starts with an A. What kind of compound is A? A hydroxyl unit is that, but that's not the type of compound. That's only the group or thing on it that helps you identify it. So what is it? Sarah is here. Okay, thank you, Sarah, for checking in. I gotcha. There's my Sarah. We're doing pretty good. Just need Riley, Tom, and Christian. If you're there, let me know. Ah, okay, I got a couple of you have it. It is an alcohol. Alcohol. Why? Because it's got a hydroxyl group on it. If it's got a hydroxyl group, that makes it an alcohol. Or in German, if you like German, it's an alkanal. Alkanol. Alkanol. Also ends in OL. Okay? Alkanol. So either language on a test, I'll take English or German answers, by the way. But you better spell it right, right? Pick your language carefully. Okay, what is B? What kind of compound is B? So we're looking for 2B. And there's no not 2B, only 2B. So what is 2B? Yes, it has a carboxylic group. In fact, that's about all it is. And remember, off here, that means there's an H out there. So you guys should be able to tell me what that is. It's not an alkanal, because an aldehyde has this. Aldehydes, Magdalena, have just this at the end. But this has more. I think we had one last time. That's why I'm asking. So it's not an alkanal. It's got an OH on it as well, which makes it what? Okay, well, you're going to learn something new, folks. Maybe we didn't get that far. I thought we did. This is an organic acid. Okay, an organic acid, okay? It's got a carboxylic group. All right, that's how you identify it. Has a carboxylic group. I think for your assignment next week, I'm going to have you name a bunch of things and draw some things, because I think you need some practice. Has a carboxylic group, GP for short. So it's an organic acid, okay? Ketone has this. A ketone, Lily, has this. It has some C's, and then one of them has a double bond O in the middle. That's not what we got here. We got a carboxylic group at the end of the molecule. So that makes it an acid. We'll talk more about organic acids in a second. How's that? Did you lower your camera? Boop. Sorry, Shilpa. Good catch. Thank you. There we go. Okay, so it's an organic acid. It has a carboxylic group. That's how we know it's an organic acid. Let's go back and give some names to these, okay? So this is an alcohol. With the number of C's, you should be able to give me a name. Here, let's write that in green in honor of St. Patty's Day, which I kind of missed anyway. So it's got 3 C's and it's an alcohol. What is this exact name for this one? 3 C's. You should know that prefix. You have to memorize them. Noah is on the way. He says propanol. Yes, propanol. And you can make it even more exact by telling me what number carbon the hydroxide group is on. So I need a number in front of propanol. Several had that. Magdalena, Sarah, Lily, Lee, Marla, Natalie, Isabella all had that. Thank you. Good. Super. But propanol. I want to know an exact name for this. Hey, thank you, my people. Yeah, thank you. A bunch of you got this. So thank you, Lily, Marla, Shilpa, Magdalena, Noah, and all of you others that I can't read that fast. Here we go. It is indeed 2-propanol. Why? Because off the second carbon, I got a hydroxyl group. So I know it's an alcohol because it has a hydroxyl group. That's the fancy name for the OH. In 9th grade, we called it a hydroxide because it was just something that was a base. But here, if it's attached to a bunch of carbons, it acts very differently. It's an alcohol. It's not just a base. In fact, it's an alcohol. It's not a base. Okay, so I've got 2-propanol. That's a type of alcohol because it's got a hydroxyl group. I've got blada blada. We haven't named this one yet. So let's put a name here for this sucker. And it's got 2 words in its name. It's an organic acid because it has a carboxylic group. This whole thing here makes it an organic acid, okay? When you see that, that's an organic acid. So, yeah, how many C's? Help me out with a name. You can at least get the prefix. How many C's? Starts with O. Okay, and it's meth. Meth is right, but it's not methanol. That would just be an OH. But it's got a C double bond O. So I thought we got that far. Okay, all right, everybody stop guessing. My apologies. This is called methanoic acid. Meth because it has 1 C. On the molecule is a C double bond O OH, commonly known as a carboxylic group. That's what that is. And it's an acid. So all acids end in OIC. OIC, that means it's an acid. And in case you didn't name that, in English-speaking countries, we act kind of stupid and we write the word acid again after that. So is it repetitive? Yeah, but do we say at methanoic acid? We do. We do. All right, I'm going to erase the other one. You guys got the alcohol, I think, or mostly. Let's talk a little bit about organic acids. My people, did we talk at all about organic acids last time? Did I at least give you one? I thought I gave you one last time. Yes, yes, no, no. Did we not have at least one organic acid? Shilpa says yes. Okay, so let's, for fun, talk about this. The methanoic acid is kind of cool. It also has a special name. You ready? If you look up on the internet, you may find it, but you'll more likely find this. It's also called, and this is the trade name. In other words, if I wanted to order some for my school, I'd order formic acid. That's the name of the stuff as a common name. This is the official name. This is what you're going to learn, okay? You don't have to know formic, but I want you to know for a reason. Okay, here's the German name. Ameisensäure. What are ameisen? What does this have to do with anything? So why would I call formic acid Ameisensäure? What are ameisen? This is a part of your German culture, in spite of the fact that I'm American, okay? There's a reason. Just keep playing with me. Anybody, what are ameisen? Type it in. Yes, I know there's a lag time till I get your answer. A lot of you know what they are. Come on. They crawl around on the ground. Green woodpeckers eat them. Okay, all right. Thank you, Magdalena. Ameisen are ants. So this is ant acid. Not antacid, but ant acid. Formic acid. It's if you get bitten by an ant and it hurts because the ant has given you some formic acid. Especially if you've been in a place like Florida, there's a lot of biting ants, and they have quite an Ameisensäure that you get if they bite you. Not wild. So that's what formic acid is. Some animals like that. Green woodpeckers are into that, so they eat those. Black bears in America eat a lot of ants, so they like the formic acid. Maybe it just tastes spicy. I don't know why, but that's Ameisensäure. Let's talk for a minute about that, okay? I want to draw it again and tell you something about organic acids. Okay, so organic acids. And you know what? That doesn't write for squat. I'm really trying to find a blue that works. I got one that I'm charging. I got another one that's kind of crap. How about this one? That's a little bit better. Okay, we'll use that one. So organic acids. Let's check this out again. So I got. No, I take it back. Let's make a new one. Let's make a new one. All right. And but by the way, the position of these is not important. I can put the C double bond O here and the OH at the top. It doesn't really matter. But important is I got all of these on one C. That makes it a carboxylic group. And I got the rest of this. Okay. Can somebody name this sucker? See, Julian K knew those were ants. Can somebody name this sucker? If that was methanoic acid, what's this one called? Give me the name, everybody. Give me the exact name for this compound. Hint, 2 C's. 2 C's. Thank you. Lee's got it. He's quick on the stick. Good question. Okay, who can answer Tadashi's question? Why aren't there more dashes on the second C? What, did I get lazy? How come I only got 3 sides with dashes? Somebody type in an answer there. In the meantime, I'm going to write down the name because a lot of you got it. So thank you to a bunch of you. Thanks to Lee. Thanks to Sarah, Magdalena, Larissa, Shilpa, Noah, Isabella, blah, 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 blah. Okay, so it is ethanoic acid. Okay, now to Tadashi's question. Why do I only got dashes on 3 sides here? So let's read a couple of answers. Sarah says, because the C has 4 bonds. It's a double bond with the O. Ah, okay. And Shilpa says it's already bonded with the double bond, and Noah as well. Good. Thank you, all of you. So Tadashi, once the carbon's got 4 bonds, it's done. Ready? Double bond is 2. I got 1 single and 1 more single. Done. So 4 altogether. I don't need a 5th bond. In fact, that would not exist. I can't have a 5th bond because the carbon, the poor little carbon, can't hold that many electrons, okay, in its outer shell. Let's see if I got any other questions or comments. Yeah, Isabella knew that too. Thank you, Isabella. Yeah, exactly. Magdalena and Larissa knew that too. Lily's, is that the same case with number B and 1C because of the O? Ah, yeah, it is. Same over here. So Tadashi, check this out. On this one, I got the same thing. I got a double bond, single, single. That adds up to 4. I'm done. 4. German 4. Okay. All right. Yeah? Good. Any other questions before we continue with our discussion of organic acids? Okay, so oic is an indicator for acid, right? So if it's oic means it's an acid, okay? That's the ending. In the same way that OL means it's an alcohol. If it ends like methanol, ethanol, those mean it's an alcohol, right? Okay, so acid, it's got to have oic and the word acid. Kind of a dead giveaway, right? Yeah, okay. Here's what I want to talk about. Folks who had me for chemistry in 9th grade. All acids give off a what? All acids give off a what? What do all gases give off? Magdalena, it's only for organic acids. Thank you for asking, Magdalena. It's only for organic acids. Okay, yeah, hydrogen ion. Thank you, Shilpa. So all acids give off an H+. But I want you to think about that. Look at all these H's. I got an H, I got an H, I got an H, I got an H. Which one? This one. That's the one that comes off. All right? So I want you to know it's not just any H, it's the one in the H part of the carboxylic group. It's that one that comes off. So I'll write in parentheses here, this one. Okay? Look at my other one. Is it this one? No, it's this one, right? It's the one that's part of the carboxylic group. That H comes off, not another one. Huge. Any other questions? Hydrogen ion, exactly. Right. Okay, so I'm going to leave that and I'll erase this one. Let's take a little side trip. Ethanoic acid. I'm going to give you the trade name. Yes, I know it's kind of silly, but if I go on the internet, it's not easy to find. Well, now you'll find it. But even easier to find is this, acetic acid. Acetic acid. That's the trade name for this. Why should you care? Because you eat it all the time. Okay. 5% acetic acid. Whoa. Hey, come on, teacher. 5% acetic acid is known as what? What famous cooking item is acetic acid in your kitchen? What famous cooking item is acetic acid in your kitchen? Citric acid. No, Lily, but a good guess. Citric acid is another organic acid. So citric acid, Lily, also has a carboxylic group, but it's pretty big. Citric acid's a bigger acid. Magdalena, vinegar is correct. So here we go. You guys may drink a lot of acetic acid if you have vinegar on your salad. Sometimes you buy like aceto, balsamico, whatever. Guess what the aceto is? That's acetic acid. And Italian, okay? I can't speak Italian, but if I could, that's part of the Italian word, I think, for vinegar. Isn't that cool? So acetic acid is a common organic acid that we use all the time. I'm going to send you a handout that has to do with making acetic acid, okay, making vinegar. It's kind of cool. It tells you how the Romans did it, and I'm going to ask you a few questions on that as an assignment for next week, okay? So it's kind of cool. I don't need to spend time talking to you about it, but it's something you could read on your own and think a little bit about. Okay, you should know that all of these organic acids have one, a carboxylic group. Yeah, I know I said that, but I think a lot of you didn't know, so I'm going to read it again. And you should have that because I sent you that, a tale of two alcohols, and the carboxylic group is on there. So if you missed that live stream, go back and review what a carboxylic group is. To make it organic, I have to have some what? One or more what? Lee knew that too. Good, Lee. And Larissa. What makes something organic? Why organic acid? What's it got to have on it to make it organic? Can you guess what element? So must have one or more. What? What does organic mean in chemistry? You probably already said this, but I can't see your responses yet. There's always a lag time. So what's organic mean? It's got to have one or more what in it. There's a bunch of responses. Whew, they're all coming at once. Yeah, Larissa, it's got to have one or more C. Yeah, one or more C. One more carbon. So that's certainly organic acid. I got two carbons, including the one in the carboxylic group. All organic acids are, I know that doesn't go with the have I got up above, are weak. That's why you can drink 5% vinegar. If it was 5% hydrochloric acid, you would burn your throat out. So, and even citric acid is a weak acid. Otherwise, you wouldn't be able to suck on a lemon or lime, okay? It would burn your throat. So all are weak acids. You need to know what weak means. Weak means an acid doesn't release its H plus that much. So I'll say limited ability. How's that? Limited ability to release its H plus. Remember, we learned in ninth grade chemistry, like strong acids like hydrochloric acid, they give off all their H pluses. So if it's in the water, a solution of hydrochloric acid, there's lots of H pluses. So you can really hurt your finger if you stick your finger in there. If I put my finger in some lemon juice, it's not going to burn my finger because only some of the H pluses come off, okay? That's true of all weak acids. They have a limited ability to give off their H plus. So they're going to be acidic, but not nearly so acidic. So let's review this. Okay, so let's talk about pH. We should review this too. You haven't heard pH in a long time, have you? pH of strong acids. pH should be like what? And weak acids. Give me some numbers here, folks. Who remembers pH? All right. pH scale. If you didn't have it, I'll tell you that neutral is 7. So folks that had it, if it's a strong acid, probably we're talking what sort of number for its pH. If it's a weak acid, we're talking about what sort of number for its pH. Good, I got a guess already. Shilpa's starting us off with 0 to 1. Yeah, I'd say even up to 2, Shilpa. So weak acid, or no, sorry, strong acid, she says that's going to be like 0 to 2. I agree. And weak acids, you got a guess for that? Now, Lee, I got to tell you, sorry, if it's 14, it's above 7 and it's a base. So it's not an acid anymore if it's above 7. So it's got to be below 7. Look, I scared everybody. Everybody's taking their responses away. Sorry if I scared you. Okay, so what would a weak be? Weak, 7 is neutral, so it can't be right on 7, Shilpa. For lower, yeah, give me a couple of numbers. Give me a couple of numbers. Yeah, something lower. Well, how about this? How about like 4 to 6? You know what I'm saying? Yeah, Shilpa, 5's a good number. All right. 4 to 6. Yeah, maybe even down to 3, Magdalena. I don't know if I go down to 2. So if I got some lemonade with a lot of lemon juice, it's probably somewhere in this, probably 5 or 6. I can put my finger in it without hurting myself. If I have 0 to 2 and I got a HCl solution in the lab for you, I'm not putting my finger in it. Okay? So let's put another example. Okay? Example HCl. Example here. I'm going to put 2 examples. One is citric. I know I didn't give you the formula yet. Maybe I will at some point. It's not so important. Citric or acetic acid. Okay, I'll use the nice name. I'll use the nice name. Ethanoic acid. You're responsible for the names that start with the number of carbons, like methanoic acid, like ethanoic acid. The trade names like citric or formic or acetic acid, you do not have to know, okay? But they're for fun because sometimes you hear them in real life, okay? Good, let's see if there's any other questions or comments from you. What unit are those numbers? Good question, Shilpa. pH is kind of weird. It's not any sort of label because it's the negative log of a number, which you might have in math this year. In fact, I'll tell you that because I don't think I told you that in ninth grade. That's worth knowing. Not part of our 10th grade curriculum, but has to do with your math class. So if you didn't know what pH is, now you do. pH is the negative log of the concentration of H plus. All right, now in chemistry, if I got brackets like this, that's what that means. It means concentration in moles per liter of solution. If you haven't had moles in a while, you'll have to look it up. But that's a really important idea, concentration. So the more acidic, the lower the pH. The less acidic, the higher the pH. Neutral is 7. Above 7 is basic, which we don't really have much to do with in 10th grade. Good. Questions? Any other questions from you? Does that help you understand organic acids and alcohols a bit? Last time I think we talked more about aldehydes. Let's do an aldehyde for review. You're welcome. Let's do an aldehyde for review. So I'll maybe put that. I'll put that over here. All right. Name this. Name this. Can you see that? Yeah, you can. Okay, shaboom, shaboom, shaboom. Boop. Remember to count your C, count your bonds on your C. Only 4 bonds allowed on your C. Don't put that extra H. Careful. Okay, what's the name of this? This is. Got a couple questions. Just confirming, weak acids are those. Sorry. Okay, sorry, Lily. Okay, let's try again. Weak acids are those that are less acidic. Yes. Yes. Their H pluses don't come off so well, so they're less acidic. They don't react as much. Magdalena, if every acid gives off an H plus, how can the organic acids be limited in doing so? That's a good question. Sometimes, Magdalena, I can make them give off their H plus, but I gotta heat them up. And that's what we're gonna do in a lab if I ever see you again. And if not, that's what we're gonna do on paper. Sometimes if I heat them up, those H pluses, Magdalena, come off easier. And so they will eventually come off. Unless I don't heat them up, in which case they won't. They won't. Like if I eat a orange, I'm going to eat some citric acid, and luckily not all the H pluses are coming off. Okay, got to guess from Shilpa. Propanol. No, careful, Shilpa. It's not a hydroxyl group. It's a carbonyl group. So look back in your notes from last time, everybody. If it's got a carbonyl group, that makes it a what? Something we haven't talked about yet today. This is a review. I'll give you the German name in parentheses down here too, by the way. In case you're going to go on in German, that'd be good for you to know. Look back, everybody. What is this thing? 3-propanol? No, no. But you're trying, Isabella. It's got a prop. Turns out it's propyl. So Isabella's got the right prefix. Propyl. No, no. Maybe we didn't do it. I thought we did. Propyl aldehyde. This is an aldehyde. Remember a carbonyl group? Got a double bond O at the end of it. That makes it an aldehyde. Okay, here's the German word. The German word for this, capitalized of course, is propanal. All right, that's the German word for it, propanal. Okay, let's review aldehydes because maybe I didn't do it enough last week. Did we have an aldehyde last week? I think we did because we talked about Erlenmeyer's rule and we ended up with an aldehyde. So let's remind ourselves what these are for. All right. All right, aldehydes have carbonyl groups. What is a carbonyl group? It's a C double bond O, right, with a couple of H's hanging on there. So it's at the end of the molecule. It's a C double bond O. No OH. That's carboxylic. Sorry they sound so similar. They're not, though. So that's a carbonyl group, and that's what all aldehydes got. And they're used to preserve biological specimens. Mr. Lee might have some critters in jars, and they probably have some sort of aldehyde keeping them in there, okay? They used to use formaldehyde. Formaldehyde is methylaldehyde, but they found it causes cancer. So probably Mr. Lee is not using formaldehyde anymore because that causes cancer. That's all you need to know about aldehydes, okay? Let's name one for grins, all right? We still got time? We still got time. So name this. All right, ready? If that's the whole molecule, gang, what is it? What is it? Give you a hint. What's the name of that thing? Please type it in. By the way, I can put I don't need a number. Some of you put numbers on here. I don't need that because it's always at the end. So you don't need a number. You know what I mean? And I could put it at the front. I could draw like this. Ready? I could go like this. It's the same thing, right? We don't care. We don't care which way you put it. It's the same molecule. So it's good. Ooh, some guesses already. Thank you. Oh, you guys are quick. Sarah's got it. Shilpa Lily. Lee has it. Tadashi has it. Good job, as does Merla and Natalie. So it is methyl aldehyde. In German, methanol. Methanol. Okay? Huge. We're not going to study aldehydes a lot, okay? You pretty much know all you need to know about aldehydes if you understand this. Any questions before we start our next big adventure? We okay? Okay, here's our next adventure, and I hope a lab that I can do with you someday. making esters. Making esters. I got a question first. Let me pause before we start something new. Okay, do we need to know the German name if we're, no, you do not. Folks, you can either, on any test with me, you can either give me, if I ask for the name, you could give me the German name, correctly written, capitalized, or the international name, okay? Either one is fine, okay? Either is okay. I'm trying to be multicultural here, all right? Because some of you are going to go in the Abitur, and some of you are going to go in diploma, okay? I'm okay with either one. Yeah, good. I just want you to take more chem and more physics. That's all. Because I got a lot of good scientists in this classroom, so you should take some more, huh? That'd be nice. Maybe do science someday for a career. There's a lot of cool things scientists do. Wish I had more time to tell you that. Okay, making esters. Essentially, here's the recipe. You got to take a organic acid, plus an alcohol, and Magdalena, to make that H plus come off of the acid, I got to add heat. I know it's not a chemical, but I'm just going to write here underneath here, plus heat. Okay, so that makes an ester. Plus something else that we'll fill in later on. We're going to do an example, and if you need to fill that in another day, don't panic. You'll know this by the end of our time together. Okay, we ready? Yeah, we can at least write the example and then see if we can get a little further next time. Here's our first example. Let's take, I don't know, let's take butanoic acid. Remember, but is 4, right? Beautiful. So I got 4. I'm going to make it an acid. Ready? But say, Mr. Wyatt, you didn't draw it that way last time. Relax. Doesn't matter which spot they're on. Okay, as long as it's on the last C, this is going to work out. Okay, then fill in with some hydrogens, like I taught you. Okay, plus an alcohol. Now I'm going to make the alcohol face this. Ready? Here comes the OH. Let's make this, I don't know, let's make it drinking alcohol. Let's make it ethanol. So, CCOH. All right? Doesn't have to be bent quite that much. Got a question. What is an ester? Lily, I'm going to explain to you all about esters in the next week. So if you don't know everything about esters yet, don't worry. You're going to know. You're going to be so full of esters. You're going to be a polyester. That's coming later. Never mind. So we'll get there. We'll get there, Lily. I promise. Let's start with the names. This was butanoic acid. This was ethanol. And now we're going to circle some stuff. Okay, so turns out when I bang these together and heat them up, the H plus I talked about earlier, that comes off. Whoop. Guess what it's going to join with over there with the ethanol? What's it going to join with? Starts with a H. So that's going to join with what over here? And I'm running out of time. I'm going to go ahead and circle it. What are those two going to form? Something you shower with, something that's in your toilet. What's that two going to form? No, not that. The other stuff in your toilet. Water. Thank you. H2O. Plus an ester. The ester, I've run out of room. So whether here, H2O. You can fill in that spot if you want. Now, we got to put together what's left, and I've run out of time. So you can just about guess what's going to happen next time. We're going to take this, right? You see it? Take it, and then get rid of this stuff. And we're going to take this and put it right on the O down here. So where I took off the H, we're going to attach two C's. And that's an ester. But we'll do that next time, all right? Okay, thanks for all your participation. I'll write this down, and we'll finish up that ester reaction when I see you again next week. All right? So be well, be safe, and we'll talk to you then. Bye-bye.